This video, this video is going to go over this solubility worksheet tied to our lecture. So in this first question, we're asked to predict whether each of the following molecules would be more soluble in water or carbon tetrachloride. And before we answer that, I just want to kind of remind everyone that the way we're going to go about this is with our rule, like dissolves like. And remember, what we mean by that is molecules with similar IMFs will interact well and be soluble in each other. And so to start this question, we really have to start by analyzing water, right? And we might want to draw the Lewis structure of water. In our other solvent choice, carbon tetrachloride, so CCl4, which if we draw the Lewis structure, we know will be a tetrahedral molecule, 4 chlorines around it, lone pairs around all of the chlorines. And we might want to identify what IMFs are present in each of these. And we know for water can hydrogen bond, it has a dipole, and LDFs. For carbon tetrachloride, it can't hydrogen bond. It's a nonpolar molecule, so all it has is LDFs. So when we think about these, we now want to return to our molecules. We're given octane and methanol. And we're saying, will octane be more soluble in water or carbon tetrachloride? And again, the way we're going to do this is if we look at our molecule octane, we're going to say that's a nonpolar molecule. So really what it can do is have LDFs, and that's going to match with carbon tetrachloride. And so we'd say this is going to be more soluble in CCl4. For methanol, when we look at our methanol molecule, and if you need to do this, draw out the Lewis structure. It'll help you see things. We can draw this out. And now we can see this can hydrogen bond, has a dipole, and then has LDFs. But the key is the hydrogen bond and the dipole. So because of this, we're going to say it's more soluble in water. In question 2, now we're going to do the same analysis. But we're going to look at it and say, okay, we have 4 molecules. And for each of them, we want to know, is it more soluble in water or octanol? And so when we think about this, again, we're going to say water and octanol. We can look up the structure of octanol if we want, but water, remember, we're going to say is hydrogen bonding is the key and dipoles. And octanol, the key is London dispersion forces. All right, so this is basically a nonpolar and polar. So when we look at the molecules, we can start to say, which of these will be polar? All right, so where do we see polar groups in this? And as we look at these, we might say, all right, well, if we look at structure A, we do see one polar group here, right? There's a ketone there, but that's it. In structure B, we have to look and say, here's an OH, here's a ketone, and here's an NH2, right? So we can hydrogen bond here and H bond here. And then in the bottom one, we have OH, 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 O. Right, so lots of chances. And so when we think about this, we can say compound D for sure is going to be water soluble. Compound C we haven't found anything on. This is a completely nonpolar molecule, so that's going to go with the nonpolar octanol. And then we look at the other two, it becomes a little harder to predict because they have both, but we might say compound A is going to be more soluble in the nonpolar octanol. And compound B is probably slightly more soluble in water, although it'll probably have some solubility in both. And that's how we can start to sort of analyze these molecules. Thank you.